Hello everyone and welcome back to another problem of the day. And today's problem is titled longest substring to form a palindrome. This is rather a hard problem. So let's have a look at the problem itself. So in this problem you are given a string S which only contains lowercase alphabets and we have to find the length of the longest substring of S such that the characters in it can be rearranged to form a palindrome. So first off, let's take an example, A, B, A, B, E. Here they have given the output that is 3, which is nothing but the length of the substring AAB. This is because AAB, when rearranged properly to ABA, we have the longest palindrome which is possible for the given string S. So first of all, let's have a look as to what defines a palindrome. So let's say we have a string ABBA. Now, this particular string is a palindrome because mainly because you can like reverse them and the order remains the same. I mean, the character and the string remains the same. That is one of the properties. But the other property is that every character is even in length. Here in this case, A has the count of 2, B also is occurring 2 times. Now, what if I include another character? Let's say C here. If I include C in the between, in the middle, it still remains a palindrome. And this is because a palindrome is possible if all the characters present are occurring even number of times and only one character is present such that it occurs odd number of times. Only then our current string can be considered a palindrome or can be converted to form a palindrome. So let's say I include another character A, B, C, D, B and A. Now in this case there are two such characters which have the length odd, which basically have odd length. In that case I won't be able to convert this to a palindromic string. So this is the basic idea behind forming a palindrome. Now how are we going to solve this? Now we are going to solve this by using the property of bitwise OR. And why is that? We'll come to know. Let's take in the first example AABE. So we have the character uh, A, A, B, and E. Let me erase this. Right. So this is the considered string. Let's call it S. And we'll be using bitwise OR. Now, why bitwise OR? Because in bitwise OR, bitwise XOR, not OR, there is a property that if you bitwise the same numbers, you have the result to be 0. So let's say you bitwise XOR 111 with 111 itself, then you will have the value 000. Meaning if you XOR the same values, then you will have 000. And let's say I XOR 010 with 100. In that case, I'll have the value 1110. And if I XOR this again with any one of these values, I'll get the corresponding value, other value. So for example, if I XOR this particular value with 100, I'll be receiving this value. So on XOR, I'll have 0 over here, 10 is 1, 11 is 0. So I receive this value. So this property is very important and it will help us to solve this problem. Now let's have a look at the algorithm itself, how we are going to solve it. So first of what we'll do is we'll create an map, let's call it map, wherein we'll be storing our indexes and we'll be storing all the corresponding XORs that we receive for the corresponding characters that we are considering. So let's have a map and we'll be storing initially the key value to be 0 with the value -1. You'll come to know why we have done this. So let's first convert. We cannot simply use these characters as it is to calculate our XOR. So what we'll be doing is we'll be considering these characters in their ASCII value and normalizing them within the range 0 to 25. So for that, let's say the ASCII value of A is 97 here. For A, you are 97. For B, it's 98. And for E, I believe it's 101. All right. Now what we'll do is we'll first consider a variable. Let's call it M1. This is nothing but the mask variable which we'll be using to store all the consecutive XORs that we'll be performing. And to perform the XORs, will not be simply converting these to their binary forms. We'll be setting the bit values for each of the characters. So for example, A is the first character in the alphabet, so we'll be setting the first bit of our like the first bit of 0, and for B in this case we'll be setting the second bit, and using that we'll be performing our XOR. Now let us store this particular mask value initially to have the value 0. We'll perform XOR of A, so we'll have 1 for the bit value to be set, and at which position we want this bit value to be set. It is represented by nothing but 97 minus 97. Since 97 minus 97 would give me 0, meaning I'll be setting the 0th bit to be 1. So on performing XOR, I'll have 0 XOR with 1, and that will give me the result 1. Alright. Now what we'll do is we'll consult if this particular mask exists in our map. Here it does not. So what we'll do is we'll simply store that result. So I'll store 1 here with the corresponding index value, that is 0. Now that is done. Now what we have to do is we have to keep a check if this particular character is occurring odd number of times or not. And how is that possible? That is possible only if the mask value that you have calculated, the current mask here is 1. If this mask calculated, if I XOR with any value between 0 to 25, which is nothing but the corresponding normalized values for each of the characters between A to Z. So A here would be represented by 0 and Z here would be represented by 25. So I'll XOR that with the current mask, and I'll store it in another variable. Let's call it M2. So my current mask value is, let me write this clearly. Yeah. So the current mask value here is M1, which is nothing but 1. I'll XOR it with 0. That is the 0th bit set for 1. On XORing, I get 1 XORed with 1 since the 0th position of this bit is set. So I'll have 1 XORed with 1, which would give me 0. And since this gives me 0, I'll make a check in my map. And this particular mask, this particular 0 value exists in my map with the corresponding value as -1. So what I'll do is I'll simply take in this particular index, which is nothing but 0 in this case, and I'll take in that particular index, subtract it with the value present in my map. So initially for 0th element it is -1. I'll subtract it, that is 0 minus of -1. It would give me the length of the current answer, that is 1. So up till the 0th index, I have 1 as my longest palindromic substring, which is A alone. So I'll be storing that in my answer variable. Now after doing this, let me erase it again. Erase this part again. Yeah. So after doing this, I'll simply move on to the next character. So the next character here again is A. So I'll use the mask again. I'll consider the previously computed mask value, which is 1. XOR it with the set bit for A, which is 97 minus 97, and that would give me 0 1, sorry, not 0, 1 XORed with 1 again, and that would give me the value 0. Now again, this value exists in my map. Now since this value exists in my map, I'll simply use that particular value, that is -1, and I'll calculate my answer. So what is my answer here in this case? Since the current index position is 97, not 97, it is 1. I'll use that 1, subtract it with the map value, that is -1, and I'll have the result as 2. Since 2 here is greater than 1, I'll store the value 2 in my answer. Now coming to the third character, which is B. Well, not M2, yeah, M1. Before moving to the third character, I forgot to tell, but we again have to make a check if this particular considered character, if it is odd in length. And for that, we'll again loop over our characters, that is from 0 to 25, and again make a check. So I'll have M2 with M1 as my mask, and I'll XOR it with the current considered character, that is 1 shifted 0 times for A. So that would give me the mask value here is 0, 0 shifted 1 time, 0 with XOR with 1 shifted 0 times. That would give me the value 1. And since it's present in the map, what I'll do is I'll simply calculate my answer. What would be my answer? It would be this particular index, that is 0 minus of minus I guess 0 again. Well, yeah, right. 0 since my mask value is 0 and and sorry, not 0, the considered index is 1, so it would be 1 here subtracted with the map value, which is 0. That would give me the answer as 1. So A alone here can form a palindromic string. So that is the answer that I'm getting over here. But since our calculated value for the answer previously calculated, it is 2, which is greater than this one, we will not be storing this. Now after this is 1, we can safely move on to the next character, which is B. So B here in this case, the previously computed M1, that is mask value, is 0. I'll XOR it with 1 shifted 98 minus 97 times, which is nothing but 1 time. That would give me 0 shifted 1, 0 XORed with 1 shifted 1 time. So that would simply give me 0 XORed with 1 0, and the result would be 1 0 itself. But will have to make a check if that bit exists in my map. This particular value does not exist in my map. So I'll be storing that value in my map. So it would be 1 0, and the corresponding index, that is the index for B, is nothing but 2. So after storing it, I'll again make a check to check if that considered value, that is this B, if it's occurring in odd numbers or not. So I'll again loop over 0 to 25. After looping over, I'll again create the mask M2. Consider this M1, which is nothing but 10. Well, not 10, 1 0. XOR it with 1 shifted 0 times for A. And if I perform the XOR here, then I'll get 1 0 XOR with 1, which is nothing but I believe, yeah, 1 1. But this value is not present in my mask, so I'll be doing nothing. I'll move on to the next character. So the next character here is B, and I'll use the same mask, that is M1, XOR it with 1 shifted 1 times. In that case, the XOR would be 1 0 XORed with 1 0, and that would give me the result as 0. Now this particular value is present in my map with the corresponding value as -1. So I'll calculate the answer. So my answer would be the current index, which is nothing but 2 here in this case. So 2 minus of this value, that is -1. And on doing that, I'll simply have the result as 3. And since it is greater than 2, I'll be storing this result. Now after doing this, I'll again move on to the next character, which is nothing but E here. So E has the SK value of 101. I'll use the previously computed mask value, that is 10. Well, not 10, 1 0. XOR it with 1 shifted 101 minus 97 times, which is nothing but 4. So that would give me 10, 1 0 with 1 shifted 4 times. And on calculating, I'll have 1 0 XORed with 1 4 times 0, and the corresponding calculated value would be 10010. Now again, this value does not exist in my map, so I'll be storing that value with the corresponding index value for e. So I'll be storing 10010, and the index value is nothing but 3. Now again, I'll have to make a check if this character is appearing odd number of times or not. So I'll move over from 0 to 25. I'll use the mask value m2. Consider the current calculated mask m1, that is 10010. XOR it with one shifted 0 times for a. I'll receive the value as 10010 XORed with 1. The value would be 10011. Since it is not present in the map, I'll be doing nothing. Similarly, I'll calculate it for b, that is the value 1 here within the range, that is 10010 XORed with 1 shifted 1 time, and that would give me the value 10010 XORed with 10. This would give me 100 right, 10000. Since it is again not present, I'll not be doing anything. I'll move to the uh, next value character, that is represented by the value 2. So I'll again calculate m2, 10010 XOR it with 1 shifted 2 times. So that would give me 10010 with 1 2 times 0. That would give me the value 100, well, not 100, 10110. Since again it is not present, will not be doing anything. So on doing this for D also, and then I'll be moving on to E. So let's consider the character E, which is represented by the number 4. So I'm moving on to 10010 with 1 shifted 4 times for E. On doing that, I'll get the value 10010 XORed with 1 4 times 0. And this XOR value would give me the result 10. Now this particular value is present in my map. It's present in my map with the index value as 2. So I'll calculate the answer again. And what would be my answer? It would be the current index, which is nothing but 3, subtracted with the corresponding map value, which is 2 here. So on doing that, I get the value as 1, which simply tells us that this particular E character, if considered alone, can form a palindromic string. So this is how we'll be solving the problem. Now let's jump right onto the code. So first off, what we'll be doing is we'll uh, take in the length of the string, and yeah, first off we'll create the length of the string. So the length would be nothing but n equal to s dot length. We'll create a map, and we'll use two values. So we'll not be storing binary values here, obviously, since they will be calculated automatically. And we'll create a map, let's call it mp. We'll have another variable answer, wherein we'll be storing our answer. We'll have variable m1, where we'll be storing our mask, initial mask, and we'll also have another variable, we'll also have another variable m2, wherein we'll be storing our mask for to calculate the occurrences of odd characters, like the occurrences of characters with odd length. And initially, I'll be storing the mask value for the index, like mask value with, for 0th value, we'll be storing it as -1. 0th key, will be storing it as -1. Now I'll be looping over a string. We'll create a variable, let's call it Yeah, let's call it temp, wherein we'll store the corresponding index value of our map. So it would be s of I minus 97. So that would give us the result. Well, let's typecast this to be on the safer side. Yeah. So after calculating the temp, we'll simply calculate our mask, which is m1 equal to uh, m1 XORed with 1 shifted temp times. And after doing this, we'll make a check if that m1 value exists in our map or not. So we'll do this and we'll call it for a map for a mask m1. And if it exists, then we'll simply calculate our answer. This is because if it exists, it tells us that the count of that particular character is even. So we'll use our answer variable. We'll be storing the answer and we'll take in the maximum value between our answer and the calculated length for the current character. That is nothing but I minus the index value for the mask m. Now after this, if the character is not present, then we'll simply be storing the mask value within a map. So m1 would be equal to I. Now after doing this, let's say we find the character, we have to make a check if that particular character is appearing odd number of times. For that, we'll simply be looping again from j equal to 0 to j less than 26. That is for 0 to 25. That is corresponding to the 26 letters of our characters of our alphabet. And I'll create a mask m2. Well, we have already created that. So we'll be using that mask m2. Consider a previously computed mask, XOR it with 1 year, 1 year shifted j times. So 0 here would represent A and 1 would represent it B. Simultaneously, like similarly for all the characters, it would be represented using the integer from 0 to 25. So after calculating, I'll again make a check within my map for the calculated mask M2, and if it exists, then we'll simply calculate our answer and we'll store the max value for our answer. So it would be between answer and answer I minus the map value, which is map of M2. After doing this, we'll have our answer and we'll simply be returning the answer. Alright, I guess we are done. We can compile. Alright. Alright, so that was it for today's video. If you have any doubts or suggestions, you can put them in the comment section. And thank you for watching.